Welcome to our video lesson on method 2 for finding the greatest common factor using factor trees. You need to write down everything that I write or the stuff that is fillable into your guided note. Method 2 is using factor trees. Alright, the first thing you're going to do is write down all these steps. So fill in the blanks on your guided note to write them down so that you have them for reference later. Pause the video now if you need some time to write it down. Now that you have the steps written down, let's use them. So we're going to find the GCF of 28 and 42. Step 1 says to write a factor tree for each number. A factor tree is when you go like this, and just start by dividing the number, use your divisibility rules, by any number you know that it's divisible by. Well, I know 28 is divisible by 2 because the 8 is an even number, and that's what it ends in. So I'm going to divide it by 2, and 28 divided by 2 is 14. Now 14, 2 is a prime number, so we know we're done with it, so I'm going to circle it. 14 is divisible by more, so we're going to divide again, and again by 2, and 2 times 7 gives 14. I circled the bottom numbers because they are the prime numbers, and they are the end of our factor tree. Let's do the same thing for 42. I know 42 is divisible by 2 and 21. Yes, 2 times 21 gives 42. 21 can be divided into 3 and 7. Then I think, is 3 a prime number? Yes, so I circle it. Is 7 a prime number? Yes, so I circle it. Now I'm done making my factor trees. It says circle the last number in each factor tree. I've already circled it, so I'll check that one off too. Write the prime factorization. This might be new to you, prime factorization. What that means is write each number like this. 28 is equal to 2 times 2 times 7. So you take the bottom number on each of your factor trees and put it together to multiply it together. And if you multiply 2 times 2 times 7, you will get 28. It's called prime factorization because each of these numbers here are prime numbers. Then 42 is equal to 2 times 3 times 7. And then we're done the prime factorizations. It says circle the common factors. So I go through and find any factors that the two have in common. They have 2, then there's 2 and 3, that's not the same, and then they have 7. Excellent. It says multiply the common factors together to get the GCF. So I know the GCF is equal to whatever 2 times 7 is. And that's 14. So in the end, the GCF of 28 and 42 is 14. That's the end of my first example. You can pause or rewind and go back and watch it again if you need to. If not, we're going to do another example. Finding the GCF of 115 and 21. There isn't space for this on your guided note, so somewhere in your notebook, I need you to write this down. Take a second, pause the video, try and solve it on your own. Try and find the GCF of 115 and 21 using whichever method you prefer. I'm going to do it now, right here. So, 115 and 21. I'm going to use the method we just went over. So using my divisibility rules, I know that 115 would be divisible by 5 because it ends in a 5. So I'm going to put 5. Then I'm going to check on the side what divided by 5. 5 goes into 11 2 times. 2 times 5 is 10. So I'm going to get a 1 and bring down the 5. 5 goes into 15 3 times. 3 times 5 is 15. And we subtract it and get a 0. And then we have 5 times 23 is 115. So I know 5 is a prime number, meaning the only two numbers that can multiply together to make 5 are 1 and 5. Now you need to think about 23. Do you know any numbers that you can multiply together to make 23? The only two numbers I know of are 1 and 23. So that is a prime number as well. Alright, 21. 21 is made up of a 7 times a 3, and those are both prime numbers. I'm going to make this neater. And those are both prime numbers, so I'm going to circle them both. My next step is to write their prime factorization. So take 115 and write that it's equal to 5 times 23. And take 21 and write that it's equal to 3 times 7. My next step is to circle any common factors. So I start by looking at the 5 and the 3. They don't have those the same. And then 23 and 7, those aren't the same either. So there aren't any. So what does that mean their GCF is? If they don't have any common factors, what's their GCF? All numbers have a GCF. If you can't find a larger one, the greatest common factor that they share would be 1. So in this situation with 115 and 21, the greatest common factor is 1. That's all for now. I'll see you later.